In this module, we're going to explore limiting and excess reagents. By the end of this module, you should be able to explain the concepts behind limiting and excess reagents. When we have stoichiometric amounts of our substances, we see that we have amounts indicated by the coefficients in our balanced chemical equation. For example, for building our snowman, if we have one head, one middle, and one bottom, we can make exactly one snowman and have nothing left over. Likewise, if we have two heads, two middles, and two bottoms, we can form two snowmen, again with nothing left over. However, in real reactions, we frequently have more of one substance than another. And so then we have to determine how much product can we actually make. Let's look at this example. We have 3 heads, 5 middles, and 4 bottoms for our snowman. So how many snowmen can we actually make? We are limited to making 3 snowmen because we are limited by the number of snowman heads we have. Once we run out of one part or one reactant, we cannot continue the reaction anymore, and so it is going to control the amount of product that we make. So even if we had 50 or 30 or 100 middles and bottoms for our snowmen, we would be left with only 3 snowmen because we are limited by the number of heads that we have. And once we run out of that reactant, we're done. Our reaction cannot proceed any further. So for this, we can define 2 new terms, limiting and excess reagents. So the limiting reagent is the reactant that is used up first in the reaction. We frequently determine this by looking to see which one will limit the amount of product that we can form. The excess reagent is the species that is left after all of the limiting reagent is consumed. Depending on the number of reactants, we could have 2 or more limiting reactants. In this case, our head was our limiting reagent, so this limited the amount of snowmen we could build, and both the middle and the bottom were our excess reagents or excess reactants because we had some of those left over after the reaction was complete, because the reaction stopped as soon as we ran out of one of our reagents. Now let's look at another example. Let's look if we're making sandwiches. Now it's not a 1-to-1-to-1 ratio like we saw with our snowman where we needed 1 of each part. Now to make a sandwich we need 2 pieces of bread and 1 piece of turkey. Therefore we have to figure out how many sandwiches can we make if we have 6 slices of bread and 5 pieces of turkey. Now I probably don't have to show you the math for you to realize that the bread is going to run out first, that we're only going to be able to make 3 sandwiches. But what we want to look at is how we're going to set that up based on what we know from our equation here, which happens to show 2 bread, 1 turkey equals 1 sandwich. Let's start by assuming that the bread is limiting. So if the bread is the limiting reagent, that means we're assuming that the turkey is the excess reagent. Now, I know that I have 6 slices of bread. That was the amount that was given in the problem. And I also know the relationship between the number of pieces of bread and the number of sandwiches I can make. And I get that from the coefficients of my balanced equation. So I know that for every 2 slices of bread, I can have 1 sandwich. Now this is the same way we looked at in the previous unit where we looked at the relationship, the mole to mole ratio between 2 substances in a chemical equation. The difference is now that we're not going to be able to do just 1 calculation to find the amount of product. We're going to have to do 2 calculations. So here, if we assume that the bread is limiting, we know that 6 slices of bread, our slices of bread cancel out with one another, and what we're left with is that we can form 3 sandwiches. So now I assumed bread was limiting. Now I want to assume that the turkey is the limiting reagent and therefore that the bread is the excess reagent. So I do the same thing I did with the bread. I have 5 pieces of turkey Again, I go to my balanced chemical equation, or my balanced equation here, to determine the ratio between turkey and sandwiches, and see that I need 1 piece of turkey for every 1 sandwich. Again, I see that turkey cancels with turkey. When I do the math, I see that I get 5 sandwiches. So what I'm looking for here is looking to see which one is produced the least amount of products. Because I produce only 3 sandwiches, when I assume bread is limiting, that lets me know that this is the maximum amount of product I can produce. And that the bread is in fact the limiting reagent. Because I run out of bread before I run out of turkey, it is going to limit the amount of product that I can form. And that's easy to see when I look at my 2 assumptions, my 2 calculations, and see that if bread is limiting, I can make 3 sandwiches. If the turkey is limiting, I can make 5. And so the lesser amount will always determine which reagent is the limiting reactant. Now, how do we recognize that something is a limiting reagent problem if we're not told that it is? What we want to look for is to see if we have amounts of 2 or more reactants. In this case, we're given a balanced equation of iron plus oxygen yields iron oxide, and I see that I have 25 grams of iron and 25 grams of oxygen. Because I'm given the amounts of both of these substances, I don't know which one is going to be limiting. And I can't simply compare the amounts and say that we have stoichiometric amounts because they both have the same mass. Because remember, when I'm looking at stoichiometric amounts, okay, everything has to be in units of moles. I can only compare moles of one substance to moles of another. I can't compare grams to directly. So without knowing the moles of each of these, I can't determine which one is the limiting reagent and which one is the excess reagent, or if I have stoichiometric amounts of those 2 reactants. So for this calculation, I'm actually going to have to do similar to what I did with my sandwich problem, where I have to do 2 calculations to determine which one will produce the least amount of product. So we'll look at that in just a minute. Right now, what I want to look at are the steps that we're going to go through to solve this problem. The first thing we're going to do is we're going to calculate the amount of product formed for each reactant given. So looking back at our sandwich example, we assumed bread was limiting and used that for a calculation. Then we assumed turkey was limiting and used that for a second calculation. Then we look at the amount of products produced, and we see the reactant, which produces the least amount of product, is the limiting reagent. So it always goes back to the reactant, but it's about the one that produces the least amount of product. It is very possible to have the less mass of a reactant be our excess reagent, because we have to look at it in terms of moles, and we have to look at the mole-to-mole ratio. Then we're going to use the information provided to us in the problem, as well as the identity of the limiting reagent, to finish our problem, to determine what the actual answer needs to be, or what units we need our answer to be in. So when we look at stoichiometric reactions, we have to worry about how much we have of each substance. In this demonstration, we're going to look at the reaction between magnesium, which is a metal, it's a solid, and hydrochloric acid. And what we have here are 3 flasks, and in the balloons we have samples of magnesium. We have 0.1 grams of magnesium, 1 gram of magnesium, and 2 grams of magnesium. And what we're going to see happening is the magnesium reacting with the hydrochloric acid to produce the hydrogen gas. And we can see which one is the limiting reagent and which one is the excess reagent, depending on how the reaction proceeds. So I'm going to lift the balloon here. This is the 0.1 magnesium, and I'm going to lower the magnesium into the container. So now we can drop the 1 gram of magnesium into our hydrochloric acid. We see a much more vigorous reaction. We see more hydrogen being produced because we see our balloon is getting larger. And now we can go to the 2 grams of magnesium. And again, we see a similar vigorous reaction between the two. And what we're going to compare is the amount of hydrogen gas produced in each of these reactions. So now that the reaction is finished on all three of them, I notice a couple of things. One, the balloon in the first one is very small, indicating that one of our reactants is completely consumed because we have the same amount of hydrochloric acid in each. So our magnesium ran out here in the first one, and so we weren't able to produce much of our H2 gas product. So when I look at the second and third flasks, I notice that the balloons are about the same size. We produced about the same amount of hydrogen gas. However, if I look at the third flask, what I see is that there is still magnesium in the hydrochloric acid. So they started with the same amount of hydrochloric acid, but I have leftover magnesium, indicating that that is the excess reagent. And so in the middle one, we actually have stoichiometric amounts of our reactant. So for every 1 mole of magnesium, we have 2 moles of hydrochloric acid. So when I look at the third flask, what I see is that I have excess magnesium. So all of the HCl has been consumed, so it's my limiting reagent and is limiting the amount of hydrogen gas that can be formed. So the magnesium is the excess reagent and the hydrochloric acid is the limiting reagent. In our next module, we'll look at the calculations for the limiting and excess reagents involving the masses of two substances.